Hi ladies, this is Mrs. Blaufuss, and today we're going to look at lesson 4.5, and 4.5 is about slope. So you probably remember a little bit about slope from Algebra 1 or Algebra 2, but slope, we can use a couple formulas to describe slope, but essentially what it is the change in y values divided by the change in x values. It's a ratio, so you should keep it in fraction form. Even if the fraction is improper fraction, that's okay. But you should always have slope in fraction form. So when we look at the slope, we're looking at the slope of a line. So we're using linear equations. And remember, we read slope from left to right. So anytime we're reading slope, we would start at the left of the line and go to the right of the line. And whether the slope goes up from left to right or down from left to right tells us whether it's positive or negative. So if you look at this line that I just sketched in, from left to right, it goes up, therefore it's positive. If I sketched in another line, in this line from left to right, it's going down. This tells me that my slope is negative. Okay, so slope can be either positive or negative, but it's a ratio, and this ratio tells us the steepness of the line. So if you remember from algebra, either Algebra 1 or you did some work in Algebra 2 as well with this, we have something called slope-intercept form. And that is y equals mx plus b. So it's a form of writing a linear equation where m is the slope. So the variable that we use to define slope is m. And we also learned in algebra that slope can be calculated as the rise over the run. And we can define rise as the change in our y values, and we can describe run as the change in our x values. That little symbol that you see, that one that looks like a triangle, that's called the delta sign, and delta means change. Okay, so anytime you see that little delta, that means change. We use a similar sign for triangle. Okay, so if you can tell we're not talking about a triangle, we're probably talking about change. So rise is the change in the y, run is the change in the x. So we can calculate slope by change in y divided by change in x. Or you may also remember using y2 minus y1. And I don't really have a way to do subscripts here, so I'm just going to write y2 minus y. Well, you know what? Let's just do this. Okay, there we go. So y2 minus y1 divided by x2 minus x1. And remember the x's and the y's, we get those from our coordinate pairs. Okay, so a coordinate pair is a point on the coordinate plane that has a value for x, or its horizontal distance from the origin, and a value for y, or its vertical distance from the origin. So let's just review how to find slope again. So again, we're going to use the change in x divided, or the change in y divided by the change in x. Okay, so here in this first example, we have, whoops, here we go. Let's look at our change in y first. Okay, so we're going from this point, where y is 2, up to this point, where y is 4. So we have to go up 2 units. So our change in y is 2. And then we want to look at our change in x. So to find our change in x, we start here at 0, where x is, in our first point, and we go over 5 units. Now we're moving 5 units to the left, so that makes our change in x negative, and it's negative 5. Okay, so our slope is change in y over change in x. So m is equal to 2 over negative 5. Or you could say m is equal to negative 2/5. Okay, it's the same thing. When you take a positive divided by a negative, you have a negative. And when you take a negative divided by a positive, it's still a negative. Okay, so it doesn't really matter if you have the negative in the numerator or the denominator, you get the same answer. The slope is negative 2/5. And we can just rationally check that because we know that slopes are negative if they move down from left to right. And in this case, this line moves down from left to right, so we know that it's negative. Okay, let's look at the next example. And here we're looking at the change in y again, divided by the change in x. And our change in y, and if we count, I'm just going to count, our change in y is 1, 2, 3, 4, 5. And our change in x is 1, 2, 3, 4, 5, 6, 7. Okay, you can look at the coordinates, or you can simply just count the units on the coordinate plane. So a horizontal or a vertical change of 5 and a horizontal change of 7 gives us a slope of 5 over 7. You should always write your slope in simplest form. Okay, so for example, if this was 5 over 10, we would want to simplify that to 1 over 2. Okay, so always write it in as a ratio and always write it in simplest form. Okay, so in this next example, we're going to look at, again, the change in y divided by the change in x. And the change in y in this case is 0. And the change in x from this point to this point is 3. Zero divided by any number is 0. So here, our slope is 0. Now, we would get the same answer if we went from the point 0.5 and to the left, because if we did that, our change in y would still be 0, but our change in x would be negative 3, and 0 divided by negative 3 is still 0. Okay, 0 over any number other than 0 is going to be 0. Okay, so no matter which way you do it, you get a slope of 0. So any horizontal line has a slope of 0. Okay, now let's look at the next one. And again, slope is the change in y divided by the change in x. And our change in y here is, and it again doesn't matter which one you go from, but I'm just going to go from the lower one. Our change in y is 4. And our change in x is 0. So our slope is equal to 4 divided by 0. Now remember that you cannot divide by 0. And so therefore a slope of 4 divided by 0 is undefined. And any vertical line will have an undefined slope. And that's because there is no change in x. Okay, you're dividing by the change in x, and in a vertical line, there is no change in x. Therefore, slope is undefined. Okay, let's look at this next example. It says find the slope passing through points -7, 4, and 2, 9. I'm just going to call, and it doesn't matter which one you choose, but I'm just going to choose this first one as point 1, and I'll choose the second one as point 2. Okay, that means that this first point, -7, that's going to be my x1, and 4 is going to be my y1. 2 is going to be my x2, because in a coordinate pair you have an x, then you have a y, and 9 is going to be my y2. So we want to find the slope passing through these points. So my slope is going to be equal to y2 minus y1. So that's 9 minus 4 divided by x2 minus x1. So remember, when you subtract a negative number, you're really adding. Okay, so I can rewrite this as 9 minus 4 divided by 2 plus 7. Okay, and when I simplify, I get 5 over 9. And that's equal to my slope. So I know that this is a line that goes up from left to right. It goes up 5 units, and to the right 9 units. Okay, so between the 2 points, the rise is 5 and the run is 9. Okay, let's look at the second example. And the second example says that we have these 2 points, but we don't know what this is. We don't know our x1. We know our y1, and we know our x2, and we know our y2, but we also know the slope. Okay, so we know that the slope is equal to 2 over 3. We also know that the slope is equal to y2 minus y1 over x2 minus x1. So let's use substitution to do that. Okay, my y2 is 3. My y1 is negative 5. My x2 is 5 minus my x1, which is unknown, and that's what we're trying to solve for. And we know that that is equal to my slope, or m. So I'm going to set that equal to 2/3 because that's the slope that's given. Okay, now I'm just going to simplify each portion of this. So I'm going to simplify the numerator. So 3 minus negative 5, or 3 plus 5, is 8. 5 minus r, I can't simplify because they are not like terms. So I'm just going to write 5 minus r. And I know that's equal to 2/3. So now I have 2 equivalent ratios, or 2 fractions that are equivalent. So to solve this, I'm going to cross multiply. So 8 times 3 is equal to 5 minus r times 2. Now, order of operations says you do the parentheses first, but I cannot simplify my parentheses any further than they already are, so I have to use the distributive property. So my left side is going to be 8 times 3, which is 24, and that's equal to 2 times 5 minus 2 times r, which is 10 minus 2r. And now I'm going to solve for my variable. And so I'm going to solve for r, so I need to isolate that. And in order to do that, I need to get rid of anything that doesn't have r in it. So I'm going to subtract 10 from both sides, and I get 14 is equal to negative 2r. And now I'm going to solve for r, and I'm going to divide both sides by negative 2. And I get r is equal to negative 7. And the question was, find the value of r. So I'm done. As soon as I find that value of r, then I've answered the question. So in this case, r is equal to negative 7, and that's our x2 point. Okay, that's what, or sorry, our x1 point. That's what we solved for. Okay, we have a couple new postulates in this lesson. The first one is the parallel slope postulate, and this says that if two distinct non-vertical lines have the same slope, then they are parallel. We have to say non-vertical because vertical lines don't have a slope. Their slope is undefined. So because we're saying non-vertical here, we're going to make a subpoint saying that all vertical lines are parallel. Okay, so in order for lines to be parallel, we can show they're parallel if they have the same slope. Our second postulate is the perpendicular slope postulate, and this says that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. You may have learned this just using a couple different words. So if slopes are opposite reciprocals of each other, then the lines are perpendicular. Okay, that's probably the wording that you heard in algebra. We have to also state that that these have to be non-vertical lines. Okay, and again, we have to say non-vertical just because vertical lines do not have a slope, therefore they do not have a reciprocal. But because vertical lines are perpendicular with horizontal lines, we're going to make a subnote saying that a vertical line and a horizontal line are perpendicular. Okay, so let's look at a couple more examples where we're determining whether or not lines are parallel, perpendicular, or neither. So we're going to use, again, the formula y2 minus y1 over x2 minus x1. And that is equal to our slope. So we have to find the slope of JK, and then we have to find the slope of LM. Okay, so let's find the slopes first. So our slope of JK would be our y2, which is -9, minus our y1, which is -2, divided by our x2, which is 5, minus our x1, which is 3. So -9 minus -2 is the same as -9 plus 2, which is -7. And 5 minus 3 is 2. Okay, so the slope of JK is -7/2. So now let's find the slope of LM. The slope of LM would be y2, which is -3, minus y1, which is 4, divided by x2, which is 4, minus x1, which is 6. Negative 3 minus 4 is negative 7. And 4 minus 6 is 2. So the slope of LM is negative 7 over 2. Oops, negative 7 over negative 2. And we always want to put our ratios in simplest form. And so when we have a negative in the numerator and the denominator, we can simplify by saying positive 7 over positive 2. Now, if you look at the relationship between these two, the numerator is the same, the denominator is the same, except that one is negative and one is positive. Okay, so these are neither parallel nor perpendicular. Okay, let's look at the second one. Our slope of JK is 3 minus 11 divided by negative 6 minus negative 4. So we can simplify that to negative 8 divided by negative 2, which we can simplify even further to 4. Now let's find the slope of LM. And the slope of LM is 3 minus 7 divided by 6 minus 7. So let's simplify that. And that simplifies to negative 4 divided by negative 1, which if we simplify even further is 4. And so since these two have the same slope, these two are parallel. So please pause the video and try these next two on your own, and you can unpause for the solution. So in this third example, we can see that the slope of JK is equal to negative 3, and the slope of LM is equal to, this should be positive 1/3 because 11 minus 10 is 1. So we can see that LM has a slope of 1/3. Negative 3 and 1/3 are opposite reciprocals of each other. If you multiply them, you get a product of negative 1. Therefore, these two are perpendicular. And then in our last example, you can see the slope of JK is equal to 0, and the slope of LM is equal to 0. Therefore, these two lines are parallel. They have the same slope. They're both horizontal lines. So that's all for lesson 4.5. So please jot down any notes or questions you have, and you can come in during dasher time or into alpha. We can answer them next time I see you. Thank you.